In 1946, when the first general-purpose computer was turned on, people got surprised by the thousand of multiplication that it was able to do in a second. But nobody was thinking that a computer could reproduce the Earth system. However, some scientists were already developing sort of AI ideas inspired by evolution and genetics. Now, let's make a jump altogether of 100 years to 2046. At the first launch of the complete digital replica of the Earth, simulating the atmosphere, the ocean, cities, forests, all the different components of the Earth system, as included. The behavior and interaction with the environment of 10 billion of people simulated by a machine. What is this for? We are going to see it together. But before, let's move back from 2046 to a few months ago, September 2023, when the temperature anomaly was the highest on record. What is happening? I may say immediately, it's climate change in action. But I know that some of you might reply or might think, well, climate on Earth has been always changing. Are we really sure? Do you remember what happened here in northern Italy last year, when it didn't rain for months? And in summer, 2/3 of Europe were affected by a drought with impacts in all sectors: agriculture, energy. There was no rain, there was not enough rain for water, not enough for rice, there was not enough water for grain maize, and the Adriatic Sea entered into the Po River inland of about 40 kilometers. I know that you might say, it's just another drought. But thanks to measurements we take every day of all components of the Earth system, through thermometers, rain gauges, satellites, buoys, flux towers, we can look back at the last 60, 80 years and understand how exceptional 2022 was in the context of the last decades. But now again, some of you will say immediately, aren't you a scientist? Don't you know that climate is actually acting on much longer timescales? And this is a very good point indeed. How can we look further back in time when measurements were not available? For instance, to understand the climate conditions when the Duchy of Milan was founded in 1395, or the University of Bologna was established in 1088. Thanks to very old trees, to speleotems, thanks to lake sediments, ice cores, and several other proxies, we can reconstruct the climate of the Earth. And for instance, realize that medieval times were actually quite warm. And that, for instance, 1540 was almost as dry and hot as 2018, the extreme year that affected Central and Northern Europe with drought, heat waves in spring and summer. And now you will say, well, we told you, but wait a minute. Thanks to paleoclimate reconstructions, and thanks to models that can simulate in modern supercomputers the coupled behavior of the ocean, the atmosphere, the land, we can go further back in time, but also look at the future, how the Earth's climate will look like in the coming 50, 100 years. And now all becomes evident. The pace at which we are warming the Earth is unprecedented. There were other periods that were actually warm, even warmer than today. But those changes were occurring over much longer timescales, thousands, millions of years. And actually, we were not even on Earth. So we have seen that we can look at the future evolution of temperature on Earth. But how can we, for instance, assess whether under warmer climate conditions will be still possible to grow durum wheat for our pasta let's say in a Puglia region. And here the AI comes to support us. We can use recent data to let the AI learn about the suitability to grow durum wheat, and let the AI look into the future. And we can see that if you're going to stop emission right now, there won't be big changes. But if we will be less ambitious with our mitigation targets, some areas will become unsuitable to grow durum wheat. And if we do nothing, as you can see from the red areas in these maps, if we do nothing, then most of the areas where actually we now grow durum wheat will become climatically unsuitable. And you might imagine what this means and the effects of such a change. Thanks to AI, we can also estimate the risk associated with extreme drought for all the different sectors: energy production, river transport, agriculture, but also for the correct functioning of ecosystems. And we all know that ecosystems are fundamental for our socio-economic development. And here you see the effect of climate change in terrestrial ecosystems under a warming scenario of 3 degrees. And you see immediately that most of Europe is going to be affected by such a change. But AI can also gives us the opportunity to look at what might happen tomorrow or in the next 6 months. We can train the AI with the work that experts have been doing in the last 20 years to draw, for instance, such a map showing hazards such as heat waves, drought, associated with the impacts on crop productivity. We can let the AI learn and give us a first guess, for instance, of a drought that is going to occur over Europe with its probability and also associated with impacts on agriculture. But AI can also be used to identify areas that in the coming 6 months may be wetter, drier than usual. And now you see. So the AI takes all the different parts of the puzzle, the tons of data we have got in the past, the tons of data we get every day, and let the big picture emerge. But you see, I have insisted a lot on data, because the AI is as good as the data you use to let it learn. And by developing AI, we should always remember that a priori, AI knows nothing about mathematics, physics, Einstein's relativity theory, but we do know. And we shouldn't forget when we design the architecture of an AI and when we do evaluation of the AI. The beauty and the power of AI is that it can reveal unexpected patterns. It can take decisions, action, successful ones, that none of us would have taken. Such as the move 37 that the AI AlphaGo took to win the match against the world champion Lee Sedol. Maybe by 2046, we won't be able to simulate the behavior and interaction with the environment of 10 billion of people. But AI, if properly managed and developed, will support us in solve the climate crisis.